Find the two x-intercepts of the function f and show that f prime x is 0 at some point between the two intercepts fx. Between the two intercepts, the function f is f of x is equal to x square minus x square minus x minus 2. So let's solve this problem. So given f of x is equal to x square minus x minus 2. So we will factorize this. So we can write f of x is equal to x square minus 2x plus x minus 2. That means the x in the center minus x, we split it up into 2, minus 2x plus, actually it's 1x. Okay, so f of x is equal to, from the first two we take the common factor x out, it's x minus 2. From the last two we are going to keep the common factor x minus 2, so we just take out 1 from x and minus 2 in the last two terms. Hence f of x is equal to x minus 2, which is common between the two, times from the first one it is x and then plus 1. Okay, so what are the x-intercepts? So the x-intercepts of the function of this function is obtained, or x-intercepts, so they're obtained. They are obtained. So let me erase this. So, oops, still the same. So are obtained by making f of x equal to 0. Because x-intercept is 0, f of x, that is y, is equal to 0. Because on the x-axis I am going to find the x-intercept. The reason this is 0, because y, the value of y coordinate in the x-axis is 0. And what is y? Y is equal to f of x. So y equal to f of x equal to 0. If we solve for that, then we will get the two intercepts of the function fx on the x-axis. Hence we can write for fx, x minus 2 times x plus 1 is equal to 0. So either x minus 2 is equal to 0, which is if I add 2 on both sides, x is equal to 2. That's one possibility. The other is x plus 1 equal to 0. I subtract 1 on both sides, so x is equal to minus 1. So these are the two possibilities, x equal to 2 and x equal to minus 1. So these are the intercepts of the function fx on the x-axis. Okay. Okay. So the question was find the two x-intercepts, which we found, of f, and show that f prime x is equal to 0 at some point between the two intercepts. So remember, if you have the number line like this, if x is 0 over here, 1, 2 on this side, okay, so this is the point 2, 0, and then if you go on the left it is minus 1. So you are between 2 and minus 1. Okay, the next part, show that f prime x is equal to 0 at some point between the two intercept. So we know f of x is equal to x square minus x minus 2. Okay, So let's take the derivative of both sides with respect to x, or d of f divided by d of x is equal to derivative of the expression with respect to x, okay, and that is equal to f prime x on the left is equal to 2x, and derivative of minus x is minus 1, okay. So let's so the derivative of f of x is f prime x is 2x minus 1, okay. The question is, when is 2x, when is f prime x equal to 0, okay. That is when 2x minus 1 is also equal to 0, because that's the derivative of fx. So 2x minus 1 has to be equal to 0 when f prime x is equal to 0, or the first derivative of the function with respect to s is 0. Then we will solve for x, we will add 1 on both sides. So we get 2x is equal to 1. Then we divide by 2 on both sides, okay. So what do we get? X value is half. Now half 0 is a point inside the interval minus 1 0, which is this one, and 2 0. Remember, half is somewhere over here. This is half, okay. So f prime x is equal to 0 at x equal to half, which is between minus 1 0 and 2 0 on the x-axis. So what does it say? That means this fx, we can apply Rolle's theorem. To fx, okay, is equal to x square minus x minus 2. Basically, Rolle's theorem says that if you find two intercepts of a function, okay, two values where the function is 0 on the x-axis, in between them there should be a function where the derivative of the function is also equal to 0. In this case, our one point on the left where fx is 0 is minus 1 0, that is x value of minus 1, y value of 0, that's on the horizontal axis, and the other point is 2 0 on the right. Now we found out f of prime x, that is the first derivative of fx with respect to x, and found out that it is equal to 0 when x is equal to half. It so happens that x is equal to half is a point on the x-axis, horizontal axis, between minus 1 0 and 2 0. Therefore, we can apply Rolle's theorem between for the function, to the function fx, x square minus x minus 2, because the function is 0, okay, has two zeros on the x-axis, between which the derivative of the function, there is another point where the first derivative of the function is also 0, which is Rolle's theorem. Hence, Rolle's theorem is valid for this function. I'll stop here today. If you have any question, comment, write me a note. If you like my video, please give me a thumbs up. That really motivates me to produce more videos. And if you like this video, share with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And please do not forget to watch me tomorrow when I'll be back with another interesting problem.